Okay, so for the last part of section 1812, we're going to look more closely at the general mechanism of the reaction. And we wrote out earlier, I wrote out for you, this is the generic mechanism. Carbonyl compound hit by a nucleophile, makes a tetrahedral intermediate, goes on to produce a product. We can actually take this general mechanism and still keep it really general, but break it down into two different possible pathways. There are, in general, overall, two mechanisms for nucleophilic addition. One mechanism, the first one we're going to look at, takes place with a strong nucleophile. And sometimes we refer to these reactions as occurring under basic conditions because strong nucleophiles are good bases. Examples of strong nucleophiles that will react under the mechanism that I'm about to show you are the Grignards. Remember, those react like they are carbanions or minuses. Sodium borohydride and lithium aluminum hydride. And remember that we treat those compounds like they are, well, they are the hydride, H- ions. Alkoxides, hydroxides, and cyanides. These are examples of strong nucleophiles that will react by this mechanism. They're the most common ones that we'll see in class. The mechanism is going to start out the same. Aldehydes, ketones are both going to react the same way, and it's going to start out the same as the generic mechanism that I showed you a couple minutes ago. We're going to have the nucleophile. All of these nucleophiles have a lone pair of electrons and a true negative charge on them. And that nucleophile attacks the carbonyl carbon and opens up the carbon-oxygen double bond, just like we saw in the generic reaction. I'm not going to draw stereochemistry like I did the first time. And we just get the tetrahedral intermediate. And then that tetrahedral intermediate, we typically protonate it with either, typically either a dilute acid, H+, or you can use H2O, that would work as well. And we end up with an OH group and the nucleophile in place. And this, depending on what you started with, this carbon might be a stereocenter. So you do have to be open to the possibility, aware of the possibility that you might be getting a racemic mixture. So that's the reaction, the way the reaction occurs when you're dealing with a strong nucleophile. We can also do this reaction with a weak nucleophile. This reaction sometimes we refer to as taking place under acidic conditions. Even though not all of the weak nucleophiles that I'm going to show you are acids, it's still how we refer to the reaction. Weak nucleophiles that will do this reaction are water, alcohols, ammonia, amines, and H2 are primary amines and secondary amines. Although the secondary amines don't really want to do this. They are not very motivated to do this reaction. It's a possibility, but it's not favorable. This reaction occurs, it starts out a little bit different than the reaction with strong nucleophile. All of these compounds here in general aren't very motivated to react. Not like what we see with the strong nucleophiles, which are all ionic compounds, and they're looking to do something. These molecules are all pretty stable in themselves. They are not motivated to come in and hit that carbonyl carbon. And so what we need to do in order to make this reaction take place is that we have to turn this carbonyl compound into even better of an electrophile than it already is. Because in this first mechanism up here, the reaction is really being carried by the fact that these nucleophiles are very strong and they are very motivated to attack and to react. Down here we've got a stable compound and a stable compound and a little bit of motivation and a little bit of motivation, but not enough to really make anything happen. So what we're going to do is start this reaction out by protonating the oxygen of the carbonyl group. And in doing this, we're going to destabilize the carbonyl group. Going to put a positive charge on the oxygen of the carbonyl group, which is a really bad idea. The molecule is going to have some resonance structures that put the positive charge in a better spot, delocalize those electrons, and stabilize this intermediate. Now, with a true charge on the carbonyl carbon, this molecule this compound is very motivated to attack, and it's going to make up for the fact that these compounds are pretty stable and not all that willing to participate in the reaction. Once we get this carbonyl compound, really reactive, then we can bring in the nucleophile, which all of these has a lone pair of electrons on the oxygen or on the nitrogen. And that lone pair of electrons will then come in and hit the carbonyl carbon. And we end up with the same product as we get in the strong nucleophile reaction. And again, the same situation. Maybe this is going to be a stereocenter depending on what you've got attached at these sites. So maybe you've got to think about the possibility of racemic mixtures. And that is the end of this section, just all looking at reactions very generically. For the rest of the chapter, we're going to look at specific examples of these reactions. So for some study questions for this section, we are going to say why are aldehydes and ketones good electrophiles? And we'll say why are aldehydes more reactive than ketones? And we'll say, what are the mechanisms for nucleophilic addition with strong and weak nucleophiles? And if you have a hard time looking at a nucleophile and knowing whether it's strong or weak, you may want to add that study question sort of a thing as well, and maybe make some flashcards. And that's where we're going to stop. And on Wednesday, we will start looking at specific examples of these reactions. If you have any questions about any of this stuff, just send me an email. I will be checking my email while I am home.